Hello, thank you very much for joining our session. So for the next 40 minutes, we will try to give you an overview of how it is to develop on the Salesforce platform. So Salesforce, it's kind of a buzzword the last years for various reasons, acquisitions, Slack, Tableau, MuleSoft, but also other stuff like AI. First, let's introduce ourselves. Tina?
Sorry, I'm Tina. I've been working at Deloitte for the last 2.5 years. I've been working on the Salesforce platform, mainly on backend and system integrations.
And I'm Menelaos. I'm a software engineer. I'm a Salesforce application and system architect. I've been working on the Salesforce ecosystem for almost 6 years now. And I'm assistant manager at Deloitte Digital here at DAC. So a few words about DAC. DAC, it's a Deloitte Alexander Competence Standard. It started back in 2018 as an innovation hub, part of the Deloitte. Now we are more than 1,200 people. In my department, we were 7. Now we're more than 200 people working on the Salesforce ecosystem. And we are working on cutting-edge technologies, Salesforce, AWS, Azure, Adobe, Oracle, you name it. So our agenda for today, 3 main points. The first one is to make an introduction to the Salesforce platform. The second one is to see how we can develop business logic using low-code tools. And the third is how we can use object-oriented programming in the platform to develop more complex business logic. So if you make a search on Google, you'll find Salesforce CRM. So Salesforce, it's a CRM tool. CRM stands for Customer Relationship Management. And basically, it's a software that helps you improve your relationship with your customers, have an understanding of your customers' needs through their customer life cycle, and help you drive your business growth with what we call Customer 360 view, knowing everything about your customers. Now, about Salesforce, it was founded back in 1999 by Mark Benioff, an Oracle executive at that time. And his vision was to provide a CRM system that is available through the internet 24/7, through what we call today cloud. It's a platform nowadays, which means you can develop your own applications and deploy them without having to manage the underlying infrastructure. It's not a static software. It has 3 major releases each year. It's about 600 pages of release notes, so you can understand that we have new features to work every now and then. Salesforce as a company has product for every need. You want to manage your service, your sales, you want to manage your marketing communications, you want to build portals for your customer or your partners, you want to do data analytics, you want to use middleware. They have pretty much a solution to help you. And also there's the App Chains. So it's a marketplace that offers solutions written by independent software vendors. If you want to build some custom business logic, if you want some custom business logic to adapt to your business needs, but you don't want to implement it yourself, you can go there and find a solution, install it into your org, and have the business logic run. But since we are technologists, we care more about the underlying tech architecture of this platform. 2 main words. It's a multi-tenant platform, and it's metadata-driven. So multi-tenant, it supports many tenants at the same infrastructure. It's a moment. And each tenant is able to customize the platform using metadata. They build custom application, build different user experience, etc. From a technical perspective, if you get a Salesforce org, there's 2 things. A multi-tenant database, which is a single multi-tenant instance of a shared database among all tenants with a single schema that stores tenant-specific metadata in data. And also a multi-tenant kernel that at runtime, based on the metadata, identifies and provides you the applications, the business logic, and the records that you should have access to. So the first thing is to see how our database works. So we use the word object. Basically, an object is the classical data table we know, plus some additional functionality. And there are some standard objects that support the main capabilities of a CRM system. So we have accounts, cases, contacts, contracts, etc. And we have custom objects that are objects that you can define in order to bring your platform back to your needs. So I will make an Alt tab, a glance overview. This right here, it's the Salesforce from the end user perspective. So you can see here, if I click App Launcher, I can see all the applications that are available into my org. But from a developer's perspective, most of the time we will spend will be here in the setup menu. And sorry. Here we can have a brief overview of schema builder. So this is a representation of our database and the relationship between the different database tables. Here we have the basic ones: accounts, leads, which are prospect accounts, opportunities, cases, contacts. These are just the basic objects, because if I do something like that, okay, it's not even easy to navigate. You can see all these custom objects, standard objects, sorry, that support the out-of-the-box functionalities of the CRM. So you can understand that it's a complex system, but you don't have to deal with every object here. You just have to deal with the objects that are relevant to your business logic. And now, if I want to navigate through my objects, through my database, I'm moving to Object Manager, so we are managing our objects, and I can click on Account. And here you can see what I told you previously. Essentially, a data table, it's a data table plus additional functionalities. Here, if I click, we can see our individual fields. We can create new fields of our own. We can see page layouts, which is out-of-the-box view forms. We can see things like validation rules, which are logic to implement if you want, for example, to say no account record is allowed to be saved on the system if the phone field it's not populated. So this is a way to ensure data integrity over your system.
Okay, so Menelaos showed some very powerful functionalities that are out of the box, but where exactly do developers come in? So it will sound kind of cheesy to say, but there is really room for everyone in the Salesforce platform. Either you are a backend developer, a front-end developer, or even if you enjoy like developing business logics but don't want really to code, so there is also low-code or no-code solutions. So on no-code solutions, you have very powerful standard APIs. There is a lot of already there resources from Salesforce to do your create, read, update, delete commands on your database, or even like pub/sub APIs. So, for example, you have an external system that needs to listen to database events on your Salesforce organization. Then you can actually do that, expose the object, and the external system will be able to listen to events. And this is like out of the box. And for example, Menelaos showed you validation rules. There is also formula fields. So in your database, in your field, so in your columns, formulas to calculate your value at that point without using code, or even roll up summary fields to do some summary calculations on your database. Then we move to low code. we have Lightning Flows in Salesforce. It's the heart of no-code solution for Salesforce. They have the Flow Builder, which is a very powerful drag-and-drop UI that you can implement business logic on. And we have it on low code because you can inject instances of using code in it, but it can be also a no-code, full no-code solution. On backend, we use Apex. Apex is very, very similar to Java, so you can very easily transition to use Apex if you are familiar with Java or any other object-oriented language. And it is very powerful. That way you can develop REST APIs. You have some special classes, we call them triggers, which are classes that get triggered with database events. So when a record is updated, deleted, or inserted. And for frontend, we have three main frameworks. We have Visualforce, Aura, and LWC, Lightning Web Components. And they are three because they followed the industry standard as it developed. So for example, Visualforce is your static like HTML and CSS page. And on LWC, we are now following React and Angular, for example. So let's see a little bit more about Lightning Flows, the no-code and low-code solution. So we have a very powerful and very, very easy to use interface. It has very familiar functionalities. If you are a developer, for example, you're going to see things like decision elements. It's your everyday if. You have loops, which are your fors. You have assignments, like regular variable assignments. So it's very easy to use if you are a coder, or very easy to onboard if you don't have experience in coding, but you want to develop business logic. And flows can be of a different type. So for example, you have database triggers, you have triggers, you have flows that get triggered from database events. You have scheduled, so you want to run a business logic at specific time intervals, for example, once a day, like a batch update on some records or something. And you have screen flows, which can work as a custom component, for example, like a user, a UI to have a form for the end user to use. To get some user input. So we have prepared a small demo for you. Let's say we have a requirement from the sales user, and he says, I want to inform the customer, to inform the user also, that a new opportunity was created, and it has an amount of more than 250,000, so it's a big opportunity. And I want all cases that our service level agreement is in violation to be updated and prop up in priority. So I'm going to show you, for example, what I said before about, Okay, what said before about having different kinds of flows. So for example, here I created a new flow and I have record triggered. I have a screen flow scheduled, have auto lands, some, you can also do orchestration. So from a flow to call other flows and orchestrate something more complex. But in our case, we created a record triggered flow. So first thing you do is have your trigger, like when is this flow going to run. So we have our object. We said in the requirements that we want to inform when the opportunity is created. And I have some special conditions here. For example, I want the state's name to be in negotiation review, and the amount to be over the specified one here. So when this happens in the database, this business logic is going to run. Okay, and I'm starting to build here my business logic. And what I'm saying is, I want to do a query in my database and get all the cases of this account that are in SLA violation to yes. So there is an SLA violation with this case. So I'm getting all the cases, and then I want to loop through those cases. So for each case, I want to check to have an if, so a decision element in our case, and branch out my logic. So I want to check to do something else for high priority cases and something else for the rest, for the medium and low priority cases. So for high priority, what I'm doing is just setting the case, creating a task on the case so the operator can see that they need to do a call to the client, because the case was already in high priority, so we need to inform to resolve the case right now. So I'm doing that, and for the rest of the cases, what I'm doing is the same thing. I'm creating a task, but the task, instead of being a call, it's an email, because they were medium to low priority, so I'm not really concerned to call the client yet. And also, I'm changing the case to be on high priority now. And at the end of the loop, after my last item on my cases, I do an update to the cases, and I create tasks, so an insert to my database. So basically, it's a very simple business logic that we can test right now. So I am at an account here, and I'm going to create an opportunity. So the amount, I'll put it at 300. Okay. And we are doing a close date here because it's mandatory. Let's say it's an upgrade. In state's name, if you remember, we had some conditions to be a negotiation review. And I'm giving a random name for now. Okay, so I'm saving this in my database. And what I should see here is that my cases, which were previously I had created a high, a medium, and a low one, are all on high priority right now. And if I open, for example, this one, I can see that I have an open activity, which is for a call that was created right now. And if I go to another case, which was previously at medium, it's now on a high priority, I see that I have a task of an email. So last thing I wanted to show you was that this, okay, it was very drag and drop, it was no coding involved, but actually everything you do, even no code on Salesforce, it's tracked as a metadata. As Menelaos said, this is what we use. You can use it for versioning on Git, of course, and it is what it's used to do your deploy in higher environments, on your states and production.
Okay, thank you very much, Tina. Now, low-code tools are nice to have, but when you have to implement more complex business logic, as you understand, if we keep adding nodes into the flow, at some point we will need too much screen real estate to identify what we have actually implemented. So Salesforce has provided us a backend language called Apex. Essentially, it feels like Java. It has the same structure, but it's tailored to meet the platform needs. So it's a strongly typed object-oriented programming language. I like to think it as a subset of Java tailored to the Salesforce platform. So language is tightly integrated to the platform. We can write code that directly manipulates records and objects. We don't have to connect with our database or anything. One really interesting thing is that, as I said before, we have a multi-tenant architecture. So this means that all the users, all tenants are operating under the same infrastructure. So Salesforce has to enforce some limits to ensure that the resources are not monopolized. So there are government limits, and you can think, for example, if you have a synchronous transaction, it can take more than seconds of CPU time. If you have a synchronous transaction, you cannot manipulate more than 50,000 records. And the point here is to ensure that we have the optimal performance of the platform. Basically, we write code that it's more like event-driven. Something happens into the database, and we have to execute some specific custom logic in the data life cycles. We have integration capabilities. We can write our custom APIs. We can use SOAP, RESTful web services to integrate with other platforms. It has its own testing, and one really interesting thing is that if you want to deploy your code base into your production instance, you have to cover at least 75% of your code base without any failing test. This is an enforcement by Salesforce. You cannot deploy anything to production if you don't meet that requirement. So for the second requirement, it will be a little more complex in terms that we open a case, we see that there is SLA violation and potential liability. So we want to inform an external system, our partner's API that provide our service capabilities for us, that we have this client with this case, and you need to take this case into high priority consideration. So I will just switch back to VS Code. I hope it's visible. The first thing we need is a trigger class. This is a specific kind of code that listens to specific events, CRUD events on your tables. This example we see, this is a trigger called case trigger, and it operates on case. And we say that this trigger operates on after insert and after update. So in Salesforce database lifecycle, we have the after and before context. The before context is we check that should this record be manipulated in that way? If yes, proceed. And the after context is what will happen after this record is manipulated. We're making a list of cases. We just operate on the trigger new variable. This is a system variable that holds all the records that are modified currently in our org. We just check if there is a violation, an SLA, we add this case to the list, and at the end we say, okay, if there's at least one case, please call this method. Which will just take all the records that we are passing, and it will construct JSON payload to be sent through our integration. So here I'm just creating an HTTP request towards a specific point. For terms of simplicity, there's no authentication or security concern. We just make a pretty straightforward call out to that endpoint. And I will go back to my instance. I will go back to this account. I will try to create a new case. The asterisk means that I have to complete this value in order to save the record in our database. So I will say that the type is mechanical. The reason is installation. I have potential liability and SLA violation, and I will save, and we have a problem. And why we have a problem? As we said previously, Salesforce has these limits, and one of the platform limits is the following, which makes sense in every stack you walk. So right now in our code base, we are actually having an open connection to our database. So we are processing a record, we're executing some logic before and after, but we didn't commit anything to the database. So at this specific point, I'm making a REST call out. So I'm coupling my code with an external system. I don't know how much time it will take the system to respond. So the platforms forbids you to perform a call-out operation at a synchronous context when you are performing a manipulation of a record. And this makes sense because you have an end user waiting there for his action to be completed. So what the platform suggests is that if you want to perform a call-out at a phase like this, you have to use a different approach. And the different approach will be the following. The first change here, it's if you see here, instead of a list of cases, I have a list of IDs. Each record on the Salesforce world has a unique ID created by the system. So I'm not holding the record itself because the record itself is a snapshot of the data at that specific moment, and I will try to perform a call-out request at the future, so at an asynchronous context. Instead, I'm tracking the ID for my future method to be able to query the actual state of the data at that moment that we will execute the call-out. So I'm back to my class. And here it's the difference. We are using an annotation, and we are saying to the system, OK, when this method will be called, I don't want you to execute the code logic at that specific time, but I want you to create a thread and execute this at the future. And here we are saying that also this method is being allowed to perform callouts. So we are passing a list of IDs. This means that I have to actually make a query to my database in order to retrieve the data at the as-is state. And here you can see what we said previously, that the Apex programming language is highly integrated with my database. I just say I want a list of cases, I'm opening brackets, and I'm writing my query. Select the fields I want from case, where ID, in case IDs. Also here, it's a fact you cannot use an asterisk that we are used to have in our SOQL, because right here, you are using resources that everybody uses. So Salesforce says, OK, if you want to make a query, you have to bring only the fields that you know that are useful for this code execution. And we make, again, our payload. I will just deploy. Let's go to the org. I'll deploy my trigger. OK, back here. I don't need to refresh or anything because I just changed something on the backend side. So if I click Save, you will see that the case was created. And now we should perform the callout, but we didn't for some reason. Let me try again. No, actually we did. If I see here my webhook, it took some seconds. So we have here our request. So
some key takeaways from all this. Firstly, code vs low code. As you saw, Salesforce has so many out-of-the-box functionalities and has so many tools, some low code, some no code, some full coding. So firstly, I think in every department, not just working on Salesforce, you need to understand the capabilities of the platform that you're working on, understand what out-of-the-box capabilities are there, what you can utilize to be quicker in your implementation, and where you need to step in and do some custom work yourself. So say you get your requirement, you choose that, okay, out of the box is not for me, or it's for me for 80%, I need to go in for some custom work. Where do you use code and where do you don't use code? So Flow is good for very quick development and very simple business logics. Because it has some limitations. For example, it's very restrictive on callouts. I think it doesn't do many callout requests, so you better go back and use Apex. And also, it's very quick to deploy flows, and they provide very quick value to the client. But more complex requirements need to fall back to coding.
Okay, so about Apex programming, it feels a little strange to develop code into this language, but it's fun. It has its capabilities. We have all this kind of design patterns, separation of concerns, the classic gang of four patterns. We have even our own patterns that are built to have a better performance into your code onto the platform. And about platform limits, okay, this might seem crazy, but at the end it helps you in your daily life. Sometimes it's not that good to have those kind of limits, but at the end it helps you to perform a mindset, understanding how is your code impacting the end user experience of your customer, of the people you're trying to help with. So you have to think, I need to make my queries run faster. If I need to process 1 million records, doesn't make sense to process them at synchronous context. So it helps you build a better mindset around coding principles. So if you want to learn more about the Salesforce platform, you can visit trailhead.salesforce.com. It's a learning platform built by Salesforce that has generic content, not just for the platform, but for soft skills, for pretty much everything about technology. And if you want to play around with your own developer instance, so get an exact copy that looks like a production environment and you can build your own custom logic, you can visit developer.salesforce.com/sign up. So that's it. Thank you very much.